How's it going, everyone? Welcome, Eulier Gonzalez. That's right. So let's take a look at in today's video of the positioning layout, where is part of how now CSS organize all of these boxes. Boxes, which is the visual representations of now all of these different HTML elements or DOM nodes, we're gonna look like on visual media, right? And the anatomy of these boxes is that, hey, you have now the content, you have the padding, the border, the margin, and by default, the layout in which these are rendering, known as the normal flow or the flow layout, right? It label all of these boxes as block, and it has a particular behavior. So this block boxes is take all the available horizontal space. It is greedy, right? And it doesn't line break. So it's gonna continue to render that, and you never see this kind of content rendering because that's out of the screen or the view viewport, right? From the browser. Then you also have, you can modify is the dimension of these boxes. And you also have another type of box, inline, which it can line break the content, right? But you can modify the height, particularly here. And also you have is the inline block, where it say, hey, from the outside, I'm gonna behave like a inline element that I don't wanna make any fuss, but I can modify my dimensions, right? And also I can line break the content here. So, because this is the normal layer, the OG layer, right? Something that CSS at the end of the day, when you don't opt into any other layer, this is by default, is gonna organize all of these different elements. So CSS is more like a compress of set of mini language or mini layout that have its own behaviors on how all of these different boxes will be displayed, right? So, because I'm gonna make a quick recap of this particular course, which is taught by Josh Komewa, so CSS for JavaScript developers. So he went through, describe, first is how you can learn, right? Some white papers that you can take a look at, techniques on how to learn, but if you really want to learn something, there will be no technique that tells you what to do. So this has to be some systematic, and again, this is my opinion, is like if you don't have the desire, there's nothing wrong about it or good about it. It's just there isn't. So, and if you try to force it, it's like going against your own nature. So, why am I mentioning this? Because that's part of the Model Zero, like the introduction of this. And then, well, what are the fundamentals of CSS, or the thing that you need to understand right before any coding, which is, hey, what is CSS? What you can do with CSS, which is applying rules to all of these different HTML nodes or DOM nodes, document object models nodes, right? And you can style in them, whether it is by defining those rules in the different files, external style sheets, or inline directly in the document, or internal style sheet, or inline, apply directly to that DOM node. And I also look at what are the properties that we can define to styling our UI element or this DOM node, the rules that allow us to select that particular node or a set of nodes, and what are the common CSS functionalities that we can use. So for example, is not only that selecting the elements, but you can select those elements based on a particular state. And I want to make a quick recap here, because this is the reason why we have, for example, pseudo classes, pseudo elements. All right, let me see if I can read the docs and describe that fairly quickly. CSS text, no, this is CSS styling, no, part of the layout, that's right. Using common selectors, here you are, that's right. And adding a class and styling, but I am interested in to look at exactly this, not only the basic selectors, all right. So whether it's by a tag or a class or an attribute, which is, for example, in this case, but also is based on a particular state that that element can be. So for example, right? So because at the end of the day, these DOM nodes represent something, okay? If I look now at the HTML here, right? Let me see if they actually, what is a pseudo class and a pseudo elements. Yeah, a pseudo class is a selector that select elements that are in a specific state. This is why I have to do this quick recap, because that will help us a lot as we're starting to build simple websites and then more complex, like heavy client interactions like games and trading apps, or even server-side applications, right? Back office, SaaS, you name it. So for a specific state here, right? And the other is the pseudo elements. So it allows you to add a whole new HTML elements into the markup rather than applying a class on existing elements, right? So what I do want to mention here, all right, is that when a very reasonable question and a good or a deep question, a revealing question is, what are the possible states that our application, that our HTML elements can be, right? So that's exactly what I'm trying to look here, and you can take a look at the CSS reference selector pseudo class. Again, this is from the MDN docs, but I want to take a look at the spec. By the way, let me see CSS model, which is the spec, right? Why is this? Again, this is to get ourselves familiar, or in my case, myself familiar, of where all of these things are coming from, you know? So for example, like this. So on the spec, right? So this is the living standard, HTML living standard. It was updated quite, oh my God, what the French stuff? 5 days ago. Jesus, those, sorry, they live in the future, man. Anyway, so here we are, right? So this living standard specifically is talking about is the custom elements. There you got it, in the canvas elements. Let me go back here real quick to see if I can. Okay, no, let me look at, because this is part of the custom elements. If I want to go to the entry point of the HTML spec, all right, that's right. Okay, cool. So, okay, makes sense. So this is the living standard. Again, I'm not going to dive deep too much into this. Just a brief overview of why I'm looking at this and the most common use cases for working with HTML. All right. So, so yeah, as you can see, this is the structure. So the introduction here, if I can read the introduction, is this. So is this HTML5, background, audience, and you know, starting to describe the specification is intended for author of document and a script that use the features defined in this specification. Implementers of tools that operate on page that use of the feature defined in this specification. An individual wishing to establish the correctness of document or implementation with respect of the requirement of this spec. This document is probably not suited to readers who do not already have at least a passing familiarity with web technologies. And in place it sacrifices, it sacrifices clarity for precision and brevity for completeness. More approachable tutorials and authoring guides can provide a gentle introduction to the topic. But I am not here to be gentle. I am here is to the truth. And the truth is not gentle. So in particular, familiarity with this basic DOM is necessary for complete understanding of some of the technical aspect of this spec. So in other words, this is why we need to build, running or doing some workshops where allow you to create some basic HTML elements that perhaps at the industry level, they don't care if you have done that. But as an individual to build up the knowledge on top of that you understand now where the current web industry are, the tech industry, particularly the web. And from there, you can say, okay, so now I understand where we are. So again, I'm just going to read the last section and then move on to look at the structure or the anatomy of the HTML. In particular, familiarity with the basic of DOM is necessary for complete understanding of some of the more technical part of this spec. An understanding of Web IDL. There you got it. So Web IDL. I don't know what is this. I mean, language used for web documents. You see? Okay. The abstract define an interface definition language. Web interface definition language that can be used to describe interfaces that are intended to be implemented in web browsers. So in other words, right, if I look now at the introduction here, so this standards define an interface definition language that can be used to describe interfaces that are intended to be implemented in web browsers. Okay, you should have this interface implemented. Imagine this interface like you are in a house, you're about to move out to some new city, and that city should have at least some of this interface. So for example, an electrical plug, right? Some of them might have Australian, European, North American, or even China or Asia, right? And so yeah, so browsers, okay, should have those interfaces, so you can work with it. So Web IDL is an IDL varying with a number of features that allow the behavior of common script object in web platform to be specified more readily. How interface described with WebID corresponds to construct within the JavaScript execution environment. It is also detailed here. So those who build JavaScript engines, right? So Chakra or Gecko, which is something that is deprecated. So JavaScript Core from Apple team, in which is also used on building modern web applications using web technologies like React Native and so on and so forth. V8, the JavaScript Google engine, or the Google JavaScript engines are now open source. I think. So all of this is up to date to implement this kind of features. Concretely, WebIDL provides a syntax for specifying the surface API of web platform objects, as well as JavaScript bindings that detail how those API manifest as JavaScript constructs. This ensures common tasks, and I highlight this thing here a lot of the time, because as we move on here in this journey, right, and a lot of people might have questions, including myself, right? For example, like the WebIDL. I didn't know this until I realized, oh, but I used that. Just I didn't know that they have, or the spec authors put a label on that, you know, to easily identify that what we're talking. So this common task is something that is recurring along the learning process, at least in today's video, and this is why I'm going to focus my attention to that. So not only the common use cases and talk about is the general aspect of these use cases, and then the specific practice of this, right? So this ensure common tasks, such as installing global property, processing numeric input, or exposing iteration behaviors, remaining uniform across web platform specifications. Such a specification describe their interface using WebIDL and the use of pros to specify API specific detail. But this is the most common thing that we do, at least for this interface, at least for the web. It's like, hey, I want to now define global properties. So for example, jQuery is a common one, all right, where it allows me to easily select elements, DOM nodes, and then work my way around with it. Okay. The other is the processing numeric inputs. That's interesting. For example, you know, processing numeric inputs. Processing numeric inputs. Processing numeric inputs. Okay. Processing numeric inputs. What are you looking right now? Is that interface processing numeric inputs, iterables, size set like declaration, platform, legacy, numeric inputs, common definitions, numeric inputs, intellectual property rights. I'm laughing because China say, really? Anthropic and OpenAI and all that kind of stuff. Say, hey, really? Anyway, names, interface mixins, using mixins and partial, callback interface, members, constants. But numeric operations. If I look at the interface, okay, this is how you can define that interface. But this is interface definition language. Okay, and then JavaScript binding. And then, yeah, JavaScript binding. And common definitions, array buffer, numeric inputs, processing numeric input. What does it mean by this? Okay, this is now, yeah. Let me look right now real quick to Google here and ask, what does it mean processing numeric input from the HTML, no, the okay, the web IDL living standard audience section. Please be my guest. All right. Refers to automated standardized type conversions and validations that occur when JavaScript values are passed into web platform APIs. It ensures uniform cross behavior for type coercions, handling overflow, and managing special values like NaN and infinite. Okay. So for example, okay, is like how these numeric operations will going to be processed and handling. Holy moly. Type coercion for numbers and handling overflow and restricting validation. Okay, good. That was very, very revealing. Okay, let me take a look here. Or exposing iterator behaviors, remaining uniform across the web platform. Good. All right. So this is what the web IDL is, right? It describes interfaces that are intended to be implemented in web browsers. Okay. So hey, those interfaces, they must already exist. All right. So now web authors like myself can consume that. And one of the common things is that how you're gonna do is the type coercion or global declaration bindings. Okay, so you must be well aware of web IDL here in order to understand the HTML living standard. HTTP, okay, which is the protocol. I don't know if where this actually lives. Is this live here? HTTP living standard, right? Holy moly! And this live here. No, but this is HTML, but the HTTP where it live. But there is no standalone HTTP living standard. Okay. The term HTTP living standard is technically a misnomer of what. Okay, but this is the HTTP. But see the living standard developer of what? Of this. Okay, holy moly. And the standards. HTTP. That's interesting. Okay, I'm getting into this. So what is this? So it's a set of standards that, well, this organization, all right, the what community maintaining and evolving HTML since, what is this, bro? What it stands for? Web Hypertext Applications Technology Working Group. Holy. Okay. It's a working group, right? Web Hypertext Applications Technology Working Group. Interesting. So in any case, again, well, HTTP, which is the protocol. I don't know how that you got it. HTTP working group. Go to the basics, bro. Go to the basics. Okay, core specification here. Core semantics of the HTTP protocol are defined by this and this. Okay. So I really love about doing this kind of stuff. Perhaps some folks out there say, hey, duh. What are you discovering? Warm water? Yeah, I am. HTTP documentation here. Okay, exactly. Got it. Got it. And this is the living standard. The Hypertext Transfer Protocol is a stateless application level protocol for distributed collaborative hypertext information systems. So, okay, and I know that, okay, let me also look at the anatomy here. The introduction, conformance, terminology, and core concepts, identifiers in HTTP, authoritative and access fields, message abstractions, routing HTTP message, representation data and metadata, methods. Holy hell. Overview and common methods property. Methods definitions, message context, request context field, expect from okay, message context field, response context field, HTTP authentication, authentication schemes. I know this is go beyond of this. Auth parameter, response, challenge, credentials. Go back, my friend. HTTP authentications, authenticating user to origin server, authentication client to proxies, content negotiation field, conditional requests. Even in the protocol, you can add conditional requests here. Range requests, status code, extending HTTP, method extensibility, status code extensibility, fields authentication, range unit, content coding extensibility, upgrade token registry, security considerations, establishing authority, risk of intermediates, attack based on file, attacks via protocol elements, denial of service attack using range, INA considerations, and reference. Holy moly. I'm going to read this, not in today's video, not at all. But I know where I have to look from this moment and on. Okay? Yeah, this is the source of truth. Let me read fairly quickly here the purpose. Here, the Hypertext Transfer Protocol is a family of stateless application level request response protocols. So there is another stateless application level request response protocols that share a genetic interface, extensible semantics, and self-descripted message to enable flexible interaction. Wait, what? I lost a little bit. Sorry. That share a genetic interface, extensible semantics, and self-descripted message to enable flexible interaction with network-based hypertext information systems. So any systems that any network-based hypertext information system, in other words, anything that implement this, any computer that has an HTTP or that implement this protocol here. HTTP hides the detail of how a service is implemented by presenting a uniform interface to client that is independent of the type of resource provided. Likewise, servers do not need to be aware of each client purpose. A request can be considered in isolation rather than being associated with a specific type of client. But in any case, this is what HTTP is. It's a family of set a stateless application. What is? Let me again. I know that I'm getting too deep into this rabbit hole. Yeah, examples, my friends. You know, examples of family. Let me go to here and then paste this. Right. Holy hell, DNS is a stateless. Oh, that's pornographic to know. And I say that because, and again, once you know the truth, it's like, oh, that's interesting. So you have now this stateless application level request response protocol. HTTP is the most common one. Domain name system is another one, right? Interesting. To resolve human readable names. Content constraint applications protocol designed for constrained device and machine to machines application in the Internet of Things. Trivial file transfer protocol. A lightweight simple file transfer protocol. So FTP is a stateful, so it remember that information. It is a protocol that have to remember information or to remember state. Okay, TFTP completes transfer through isolated independent request acknowledge block. Okay, and then you have the user data protocols. Operating at the transport layer, UDP is a connectionless and stateless protocol. Okay, that's interesting. Okay, and what is the difference, right? And what is the difference between blockchain and what protocols exist for the blockchain? If that is a valid question, you know. Blockchain is a distributed ledger architecture where the application protocol discussed earlier, like HTTP or DNS, are communicational frameworks. Exactly. So what are the communicational framework for the core different stateless protocol versus blockchain? So state management, application protocol like HTTP are stateless. Every request is an isolated. Blockchain is a stateful. Data storage, application protocol transmit anything. Protocols that powers the blockchain. Okay, the communication here. Protocols that powers the blockchain. So proof of work, Ethereum is execution layer, proof of stake, and Solana is proof of history. Networking, peer-to-peer protocols. Okay. Layer 2 protocol, scalability and routing. Okay, the layer 1 is the base one. It's a protocol that uses proof of work consensus. It detects how nodes validate financial transactions and mine new block. And then you have now the layer 2, which is scalability and routing. So you have the Lightning Network and the roll-up protocols. And then you have the centralized application and storage protocol here. Oh my God, okay, that is exploding in my mind. Okay. So again, why am I mentioning this? So, and it all starts with the CSS. Looking at the CSS spec, and to understand particularly looking at the HTML living standard here. So okay, I wanna go back here, right? Trace back, or doing this as the machine learning folks known as the backward propagation, right? Or going backward here. I am here. I asked the question of blockchain and the stateless protocols is because I want to know what is the difference between this blockchain and this family of stateless protocols, application level, request response base. Okay, but again, this is a way of how now hypertext systems or web servers, which is applications that live on a computers, and as long as you have that particularly participation in the network as an hypertext protocol, you can now send documents to this. Okay, so that's good. These kind of protocols like DNS, HTTP, and TFTP, right? All of them they don't care about the state of the they don't store any piece of information here, and they are at the application level, request response. Okay, so far so good, right? So I can do this. So as long as you have computers connected using hypertext applications. Okay, so as long as you have a computer connected with others using hypertext applications, HTTP, TFTP, and DNS are protocols to communicate between them. Okay? Now, blockchain is a technology, okay, to hold. So it's a stateful technologies to distribute records across computers. Oh my God, that makes sense. So blockchain is a stateful technology to distribute, or for distributing exactly, records across computers in the network. Okay. Okay. So if you want to communicate to that before a block can be added to a new ledger, the node must talk to each other. And this protocol manages how data propagates across the decentralized network. Okay. So blockchain is a stateful thing. Exactly. So network and P2P protocols. A family of communication protocol used by networks like Bitcoin, gossip protocol. So in order to keep the ledger, updated, or in order to keep the layer consistent, yeah, so in order to to keep the layer consistent, nodes in the blockchain networks use gossip protocols. Okay, and I know why they call gossip. It's like, hey, this is the new state of the of this layer. Okay, hey, this is the new state of the layer. Keep in mind, remember it. Okay, use the gossip protocol. Holy fuck. Use the gossip protocol. Exactly, use the gossip protocol. So pretty much like HTTP and TFTP to communicate each other. Okay. You have things inside this concept perfectly. Your understanding of how these pieces fit together is spot on. I don't know. You are generating things. To lock in this, here's a quick validation of your point and one small important distinction between how gossip and HTTP FTP behave in practice. The communication layer, exactly, you're exactly right. Right? This is the protocol, the mechanism. Okay. Blockchain as a stateful distribution. Exactly, blockchains as a stateful distribution. And gossip protocol versus HTTP and exactly. Again, I know HTTP has this way of doing things, but I don't know how gossip protocol works. Okay. Your intuition is correct. Gossip protocol is used by nodes who talk to each other just like HTTP. However, they use completely different structural patterns to move that data. So HTTP and FTP are point-to-point, direct. They use a strict client-server or peer-to-peer request-response model. Computer A talks directly to computer B. Yeah, because at the end of the day, they just want us to communicate. So the problem that the TCP is solving is that how you can now control the network. And it turns out that instead of controlling the network, so create now a protocol of how they communicate at peer-to-peer. This is what Jesus. So TCP IP solve the issue of controlling a network when it's scaled by, instead of managing who gets instead of managing so instead of managing control borders of who can get access to it controls or it defines exactly, it controls how the communication happens between nodes. So it is safe to say that. Exactly. Which is protocols like HTTP and TFTP are based upon. Okay. Gossip protocol is epidemic, floating. It's epidemic. Holy hell, is propagating this. Instead of a target message, gossip works like a virus or a rumor in a crowd. Okay. No, like a virus, bro. Node A connects to just 3 or 4 random neighbors nodes and tells them about a new transaction. Wait, what? Node 8 connect to just 3 or 4 random neighbors nodes and tell them about a new transaction. Oh, holy fuck. It's like telling to my neighbor that, hey, this is the new state of the... I'm about to create a transaction, bro. Holy fuck. Within seconds, the data exponentially floods the entire global network without Node A ever having to talk to every computer directly. The big picture put together. When you click send on a crypto wallet, your action combines both of these concepts. Your wallet uses HTTP via JSON or CP to send directly request to a single blockchain node. Exactly. So hey, I received this message, right? And then that blockchain node, single node takes your transaction, that takes your message and the transactions, and throw into the network using the gossip protocol, scattering into thousands of other nodes. The nodes use consensus rules to agree on the transactions, updating the state of the ledger. Would you like to explore how specific consensus mechanisms like proof of stake? But this is if you use not proof of stake. You have hit on the exact philosophical and architectural breakthrough that made the internet successful. Okay, I don't know. Again, this is just words generated by LLM, so be skeptical about it. So to expand on your point, you're describing the end-to-end principle, which is the foundation design philosophy of the TCP IP suite. Here's how TCP IP solves the scaling issues by changing where intelligence and control live in the network, the always centralized border controls. Exactly. The problem is as the network grew, these central protocols points became massive bottlenecks. If a central switch failed, the whole network collapsed. The TCP IP weights say smart endpoints, dumb networks. The creator of the TCP, Vince Cerf and Bob Ken, flipped this model upside down and say they designed a dumb network with smart endpoints, IP and TCP transactions. This is the address. Doesn't care who you are, what data you're sending, or whatever you have permission to access. Its only job is to look at the package and move it on hop closer to the destination. And the TCP transmission protocol lives entirely on the endpoints, the computer talking to each other. Okay, the ultimate parallel blockchain. This is why blockchain is so fascinating. It is history repeat itself. Just like the TCP scaled the internet by removing central network controllers and defining standard node-to-node communications protocols, blockchain scale trust by removing central gateway keepers like banks or tech giants and replacing them with node-to-node consensus protocols. Both technologies achieve massive scale by replacing a central controller with universal set of communications rules. Would you like to dive deeper into how IP layer handles routing? No, again, this is going to be on the scope of today's video. But that's interesting. So, oh my God. I didn't want to. Yeah, that wasn't mean to. I really don't want to take this time to. Well, I'm going to create a new note from that. you know. Yeah, it's like it all start with the okay. So let me put it here is the question that I make here, right? Let me just put it the question, you know. I put here the question, you know. So what's the difference between this one? Okay, and we're talking about protocol. Example of family of a stateless. Exactly. Let me put it here. So what are or what is exactly? So what is the family of a stable application level request response protocol? I think that's a good starting point, you know. And here we have now HTTP, TFTP, DNS, right? And then another question is like, okay, so what's the difference between this one, you know? Come on, okay. No. Okay. Then is another question. So what's the difference between blockchain, right, and what protocol exists for the blockchain? Yep. Exactly. And what protocol exists for that? You know, you have the Bitcoin protocol. So as long as you have a computer using, exactly. So what's the difference between blockchain, right? Yeah, what's the difference between blockchain? Blockchain is a stateful technology for distributing records among nodes, right? That's the whole point of this. It's a stateful technology for distributing records among nodes. Okay, so that's good. That's good. So again, so what protocol exists in the blockchain? You know what I mean? So what protocol exists in the blockchain? Well, you have now is layer 1 protocols, right? The base layer. So layer 1 protocols, right? So for example, it's the Bitcoin protocol, all right? Okay, so you have now the Bitcoin protocol, where it say, hey, this is known as the proof of work. Okay, makes sense. Okay. And then you have now Ethereum protocol, which is, oh my God, you have to do your work, bro. Okay, so this is proof of work. Yeah, that's right, proof of work. Yeah, layer 1. Layer 1 protocol. And you have now the Ethereum protocol, right? Which is now a proof of stake. Okay. Proof of stake. All right. And then you have now Solana protocol, proof of history. A cryptographic clock that timestamp transactions before they reach the consensus state to drastically speed up the processing time. And then you have the Solana protocol, Solana protocol. Okay. I didn't definitely want to do this. Proof of history. So proof of history. Proof of history. Okay. This is layer 1 protocols, right? Way in how they're gonna communicate to the blockchain, to this layer, distribute records, right? So Bitcoin say, well, I'm going to now in this layer have these transactions, and it has now a fixed supply. And then you have now the proof of stake, which you say, hey, well, it's more involved like how companies actually works, and when you have now a board of member, and they have now voting powers and so on and so forth, you know. Then you have now proof of history. I don't know what it is. And then you have now is layer 2 protocols. The Blockchain Academy. Okay. Top 5 layer change. And all of it come from like, what is different between layer 1, layer 2, and layer 3? Top 5 layer change versus top 5. And what is the difference between the layer and the different layers here? Understanding the foundation of blockchain, the Blockchain Academy. Build AI skill to secure your future. Oh my God. To secure your future, man. Yeah, the Blockchain Academy. Okay. In California, right? The Blockchain Academy here. Okay. And the other is this. Binance Square. Okay, okay. So this is my source, right? So sources. Sources here. Right. Dig it. I didn't make this up, bro. So trust me, bro. Okay, it's this one. Bitcoin protocol. And the other is this particular article here, right? From some random folks here. Okay. It has now like 5 replies and so on and so forth. Okay. 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 So this is these protocols, all right? And Solana, all right? Okay. Okay. And then you have now the layer 2 and the networking peer-to-peer protocols. Okay. And the gossip were DEFCON archive. And a family of the blockchain versus hash rate comparing distributed layer technology. Proof of blockchain. Cons of blockchain. What is hash graph? Well, this is describing is that blockchain and hash graph. Yeah, and investing in this distributed technology, man, because yeah, distributed layer technology, man. Yeah, but it is. Blocks are supported by a hash function which helps identify and synchronize records by differentiating and separating them from one to another. But it doesn't pull any. Oh, it quote himself, blockchain development service. Okay. Orion protocol. Quantum. Oh, they are an agency here. In Upwork. Baker Inc. Okay. In Tallinn, Estonia. Why I'm not surprised, man? Why am I not surprised, man? Yeah, why am I not surprised, man? Absolutely. Yeah. Why am I not surprised, man? Okay. 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 Again, it's based on this. I'll prefer to later on dive deep into that, right? DEFCON articles, you know. This is part of the Ethereum. Okay. Okay. But again, this is the protocol that exists, you know. Layer 1, this is the protocols, the communication, the networking peer-to-peer communication. Okay, I will say that that'll be something good to add here, you know, at least to know that they exist, right? Makes sense. Okay, and then you have is this. So gossip protocols. Okay, yeah, so I need to do my own work. So gossip protocol for Bitcoin, used by network like Bitcoin. Okay, for example, Bitcoin. Exactly. So okay, Bitcoin. Awesome. Okay. Rollup protocols, optimistic CK, layer 2 scaling framework for Ethereum. Okay, and layer 2 protocols, which are focusing on scaling and routing. Exactly. Scaling and routing, bro. So you have now, oh my god. So you have now the Lightning Network, okay? So you have now the Lightning Network. Roll-up protocols. Exactly. But this is on top of the Bitcoin. Bitcoin protocol. All right. And then you have now the optimistic CK, which is roll-up protocols, bro. Roll-up protocols. Optimistic CK in zero knowledge, right? Which is for Ethereum. Which is for Ethereum protocol. Okay, and again, I need to take a look later on this Ethereum legacy and Leap P2P. And Leap P2P for the Ethereum. Let me put it here. Ethereum protocol. Yeah, and I get it why a lot of people actually are pumping this. And I get it why a lot more. Yeah. It's like there is a lot of money involved, but There's a lot of money involved. That's what happened. That's what happened. Okie dokie, bro. That's a lot of. That's a lot of that. Okay. Okay. So. Okay. How blockchain integrate with the request response model, right? Is allegedly based on this, right? Blockchain oracles, their important types, and this crypto APIs and Epixel MLM software. You got this. So this is my question, right? Or my summary, right? Or my introspection. So in introspection, okay? So I say is this. So as long as I have a computer connected with others, to others using hypertext applications, HTTP, TFTP, DNS, are protocols to communicate between them. But blockchain is a stateful technology for distributed records across computers in the network. So to keep the ledger consistent, nodes in the blockchain network use the gossip protocols, pretty much like HTTP and FTP, to communicate to each other, with each other. So as long as you have a computer connected with others using hypertext applications, okay, HTTP, FTP, and DNS are the protocols to communicate between them. So blockchain is a stateful technology. I think that I summarized this for distributing record across computers in the network. So to keep the ledger consistent, nodes in the blockchain network use the gossip protocol, pretty much like FTP and TCP, to communicate each other. The way how it works between web protocols and blockchain protocols is when they divert. So this is the introspections of this. Okay. Right? Exactly. So this is the introspections here. So it is TCP. So TCP solves the issue of controlling a network when it's scaled by instead of managing control borders, of who can get access to, it controls how communication happen between nodes, which is a protocol like HTTP and FTP are based upon. Okay. This is known as the end-to-end principle, or end-to-end principle. Okay. End-to-end principle. Got it. I design principle in computing network that requires application specific, such as reliability and security, to be implemented in the communicating end nodes of the network instead of the network itself. intermediary nodes such as gateway and router that exist to establish a network may still implement these features to improve efficiency, but do not guarantee end-to-end functionality. Okay, according to the end-to-end principle, right? So there might be a lot of middlemen in the middle, or women, or pals, or Therians, you name it, to do this. Application transport and internet links until they get that. Okay. So this has been an effort from a lot in the pre-ARPANET era. In the pre-ARPANET era. Okay. And as you can see, these are now protocols. Let me put it here. But these now are protocols end-to-end principle. Really? But these are problems to solve now, military issues, you know. Okay, so this is why when you think that you're working with this technology, web technology, blockchain technologies, there is a geopolitical component behind this. And again, I don't want to get political here, but it's part of the intersection of your field. Oh my God, I didn't. Yeah. But in any case, I think this is a nice article that I can write it down. All right. So that'll be all for this video. Take care. Bye bye.